Okay, 10-2 is the last type of function that we have to learn this year. It is the cubed root function. Okay, so we're going to start off with the parent function like we've been doing on all the others. And it is a cubed root, so it's got a little 3 up there, of x, the cubed root of x. Now, let's think about x. X can really be anything, right? It can be all real numbers because you can take the cubed root of any number, whether it's positive or whether it's negative. So your domain is going to be all real numbers. There's no limitations on x. So when we make our chart, we can use some positives and some negatives and 0. I think I'm going to go ahead and put 0 right here in the middle because the cubed root of 0 is 0, right? 0 times 0 times 0. Now, what other numbers should we use? Well, definitely numbers that are easy to do, like the cubed root of 1. Well, that's 1 because 1 times 1 times 1 equals 1. How about the cubed root of negative 1? Well, think about what this would have to be to give you what the answer would be if this is a negative 1. Well, negative 1 times negative 1 times negative 1 equals negative 1. So that means the cubed root of negative 1 was indeed negative 1. Okay, other numbers. Let's see. 8 is real easy to do, right? Because the cubed root of 8 is 2. 2 times 2 times 2 is 8. Likewise, a negative 8 will give you a negative 2 because negative 2 times negative 2 times negative 2 worked out to be negative 8. Okay, so it looks like we're not really going to have a limitation on y either. But let's graph it and see what it looks like. So my x values I have from negative 8 to positive 8. 1, 2, 3, 4. And my y values, I need to head up to 2 and negative 2. I'll do 4. Alrighty, let's graph those. See how they look. Okay, the negative 8 gives a value of negative 2. The negative 1 gives a negative 1. The 0 a 0. The 1 a 1. And the 8 a 2. It's kind of a snaky looking graph. I'm going to show you just a couple of the ones that the book has. Sometimes it's easier to see it when you have a nicer looking graph. So see, it's kind of like an S or a snake. Here's another one here, and there's 2 right here. Now, guess what? We are not going to have any limitations on the y. So the range is also going to be all real numbers. Well, it looks like it's kind of short here, but the further out I go, the more that would end up going up. Okay. The rules are going to be the same. If you add or subtract to the function, it's going to move up or down. And if you add or subtract inside of the root, it's going to move right or left. So, for example, 2. To this parent function, go ahead and compare what the cubed root of x plus 4 will do and what the cubed root of x plus 4 will do. This is going to move up 4. It's a vertical translation. And this one right here is going to go left 4. It is a horizontal translation. Let's see. What else do we need to cover in here? I guess we should look at the rate of change. example 3. We're going to have a function. Let's do the cubed root of x minus 1. Now just realize it's this graph shifted right 1, so it's going to kind of be right in here. The snake just moves over. Now for this, I want you to look at the average rate of change, and let's go from an x of 5 to an x of 9. Okay, so you need to evaluate the function at 5. That's going to be the cubed root of 6. And you're going to evaluate the function at 9. That's going to be the cubed root of 10. Do you remember how to do cubed roots on your calculator? Okay, let me clear mine out a little bit. Remember, you have this function that says math, and the fourth one, let me move it out of the light a little bit, is your cubed root. So if I wanted to calculate the cubed root of 6, I would get about 1 how about we say 82. Do you see the mistake I made? I added 1. How about we just go ahead and make this a plus 1 so that I don't have to redo everything? Right? 5 plus 1 is 6, and 9 plus 1 is 10. Okay, let me go ahead now and figure out the cubed root of 10. Remember, you're going to pick the math, and it's the fourth one down for cubed root of 10. And I'm going to get about 2.15. So for the average rate of change, I would have to subtract the y's and subtract the x's. So the denominator is easy. That's a 4. And I get a 0.33 for the numerator. So divide by 4. And my rate of change is approximately 0.08. Make sure you're doing this on the calculator with me. Okay, for that same function, let's go ahead now and figure out the average rate of change. Okay, I'm going to keep it from 5 to 9, but this time let's make this example 4, and for the function, let's use the one that I was supposed to have used up at the top. Let's do the cubed root of x minus 1. Go ahead and pause the video and try that one on your own. Cubed root of 4, about 1.59. The cubed root of 8 is 2. Didn't even need the calculator for that one, right? 2 times 2 times 2 is 8. So the rate of change would be a subtraction. 4 in the denominator again. 0.42 in the top. Average rate of change did you get 0.1? Great job. All right, let's see. Looking ahead of your homework, you are going to have some where you're saying how it moves, and you're going to have some where it's an estimate in an interval. The only other kind you're going to have is you're going to do some estimations. And I think that's about all we need to cover in this section. I will look through it, and if I think there's anything else that we need to talk about, I will add an addendum to this video.